Welcome back to KrossUSA channel. From towering forest giants to precision milled lumber, today we're taking you inside 3 world-class sawmill operations that combine centuries of craftsmanship with cutting-edge technology. Whether you remember the old days of hand sawing or you're fascinated by modern timber processing, you're gonna love what we're about to show you. Let's get started. Deep in the heart of Europe's finest forests, where oak and beech trees have stood for generations, there's a symphony of precision and power taking place. Welcome to Koddenbrock GmbH, a family-owned hardwood sawmill that's been perfecting the art of timber processing for decades. Today we're taking you behind the scenes to witness how these magnificent trees journey from forest giants to premium lumber products. You know, there's something almost poetic about watching a skilled harvester operator at work in the forest. These aren't your grandfather's lumberjacks with axes and crosscut saws, though those men certainly earned our respect. Today's harvesting equipment combines computer-controlled hydraulics with GPS positioning systems, allowing operators to fell, delimb, and buck trees with surgical precision. The harvester head grips the trunk, cuts through decades of growth in seconds, and processes the tree while it's still suspended in the air. It's remarkable how technology has transformed what was once back-breaking labor into an orchestrated dance between man and machine. Once these hardwood logs are harvested, they're loaded onto specialized timber trucks using hydraulic loaders that can position each log with remarkable accuracy. These aren't just any trucks, mind you. They are purpose-built haulers designed to carry loads that would make your average 18-wheeler look like a toy. The logs are carefully stacked and secured, then transported to the Koddenbrock facility where the real magic begins. As those trucks roll through the mill gates, they're entering a facility that represents over a century of accumulated knowledge in hardwood processing. Koddenbrock specializes in European hardwoods, particularly oak, ash, and beech, species that have been prized by craftsmen since medieval times. These aren't softwoods like pine or fir that grow quickly and process easily. Hardwoods are dense, complex, and require specialized equipment and expertise to handle properly. The first stop in the mill is the log yard, where incoming timber is sorted by species, diameter, and quality grade. This sorting process is crucial because different logs will follow different paths through the mill. A premium oak log, destined for furniture veneer, requires completely different handling than a smaller ash log headed for flooring blanks. The yard foreman, often someone with 30 or 40 years of experience, makes these critical decisions with just a glance. It's the kind of knowledge you can't learn from a textbook. From the log yard, selected logs move to the debarking station. Now, debarking hardwoods is considerably more challenging than debarking softwoods. Hardwood bark is tougher, more deeply furrowed, and clings to the wood with stubborn determination. Koddenbrock uses ring debarkers, massive machines where the log passes through a rotating ring fitted with hydraulic arms that press cutting tools against the bark. As the log moves through, these tools strip away the bark while preserving as much of the valuable wood beneath as possible. It's a balance of aggression and finesse. Here's something interesting about bark that many folks don't realize. It's not waste. The bark removed at mills like Koddenbrock is processed into mulch for landscaping, burned for energy, or even processed for tannins used in leather production. In the old days, before environmental consciousness took hold, mills would pile up bark and let it rot, or just burn it in open piles. Today's operations waste virtually nothing. After debarking, the logs proceed to the scanning station. This is where modern technology really shows its worth. High-resolution cameras and laser scanners examine each log from every angle, creating a detailed, 3-dimensional model in the computer system. The software analyzes the log's taper, any visible defects, and its overall geometry. Within seconds, it calculates the optimal cutting pattern to maximize yield and value. Remember, with hardwoods selling for premium prices, every fraction of an inch matters. The difference between getting one more board out of a log or not can mean hundreds of dollars. The primary breakdown saw is where logs transform into cants and thick slabs. Koddenbrock's head rig, that's the industry term for the main saw, is a marvel of engineering. We're talking about a bandsaw blade that's often 12 inches wide and 30 feet long, running at speeds that would make it invisible to the naked eye. The blade is thinner than a dime, but harder than tool steel, and it can slice through a 30-inch oak log like butter. The key is maintaining perfect blade tension and keeping it sharp. The saw filer, the person responsible for blade maintenance, is one of the most respected positions in any sawmill. A dull blade wastes wood, creates rough cuts, and costs the mill money with every board foot it processes. As the head rig makes its initial cuts, the log is rotated and repositioned by computer-controlled setworks. Each cut is precisely positioned based on that earlier scan data. The operator monitors the process, but much of the work is automated. It's a far cry from the old days when sawyers relied entirely on eye and experience to position each log. The cants and slabs coming off the head rig move to the resaw line. This is where those thick pieces are further broken down into lumber of various dimensions. Koddenbrock runs multiple resaw operations simultaneously, each optimized for different product sizes. Some produce 1-inch boards for furniture stock, others create 2-inch material for flooring, and still others cut thicker timber for structural applications or specialty products. Throughout this process, edgers trim away the irregular edges from each board, creating clean, straight edges that meet grade specifications. The edger operator watches for defects, knots, splits, mineral staining, and positions each board to minimize waste while meeting quality standards. In hardwood processing, unlike softwood, each board often requires individual judgment calls. You can't just set the machine and walk away. One of the most fascinating aspects of Koddenbrock's operation is their grading system. As boards come off the production line, experienced graders examine each piece. They're looking at color consistency, grain pattern, the size and location of knots, and dozens of other factors. Hardwood grading rules were developed by the National Hardwood Lumber Association over 100 years ago, and they're still the industry standard today. A board graded FAS, that stands for firsts and seconds, must meet strict criteria for clear wood. It's the top grade, the cream of the crop, and it commands premium prices. Lower grades like Select, number 1 Common, and number 2 Common have their markets too, but that FAS material is what furniture makers and high-end millwork shops are willing to pay top dollar for. The sorted lumber then moves to the drying kilns, though that's really the beginning of another chapter in the wood's journey. But before it gets there, the fresh sawn lumber is stacked with precise spacing sticks. We call them stickers, between each layer. This stacking pattern allows air to circulate around each board during drying, preventing mold, staining, and uneven moisture content. It's a detail that matters tremendously in the final product quality. This tradition of craftsmanship meeting innovation is what keeps operations like Koddenbrock at the forefront of the industry. They're processing wood that will end up in homes, offices, and furniture pieces around the world, and they take that responsibility seriously. Every board that leaves their facility carries with it not just the rings of the tree that produced it, but the skill, care, and expertise of everyone who handled it along the way. Let's head across the Atlantic now to the great forests of North America, where Dixon lumber has been a cornerstone of the timber industry for generations. This is where American hardwoods, cherry, walnut, maple, and hickory, are transformed from standing timber into the lumber that's built everything from colonial-era furniture to modern kitchen cabinets. The story begins, as it always does, in the forest. The eastern hardwood forests of America are different from their European cousins. Here, you'll find mixed stands where a dozen different species might grow side by side. A harvesting crew might fell oak 1 hour and cherry the next, each requiring slightly different approaches. The forest environment is more rugged too, with steep hillsides, rocky terrain, and weather that can swing from scorching summers to brutal winters. Modern harvesting equipment used by Dixon's logging contractors includes feller bunchers for smaller timber and traditional harvesters for select cutting. Now, here's something that's changed dramatically over the past few decades: sustainable forestry practices. Back in the day, loggers would clear-cut sections of forest, taking everything regardless of size or species. Today's forestry is far more selective and scientific. Crews mark individual trees for harvest based on forest management plans that consider growth rates, species diversity, and long-term forest health. It's not just about taking trees, it's about managing a renewable resource for future generations. When you watch a skilled feller buncher operator work, you're seeing artistry in action. These machines can grab a tree, cut it at the base, and lay it down in a precise direction, all while the operator is planning the next 3 or 4 cuts. It's like watching a chess master think several moves ahead. The goal is to harvest efficiently while minimizing damage to surrounding trees and undergrowth. Every tree left standing is a future harvest after all. Once felled, the trees are delimbed and bucked to length right there in the woods. This is where the sawyer's skill comes into play. They're not just cutting logs to a standard length. They're making value judgments with each cut. A clear section of trunk might be cut into 16-foot logs perfect for lumber, while a section with heavy branching gets bucked shorter for pallet stock or pulpwood. The difference in value between these decisions can be significant, and experienced sawyers develop an almost intuitive sense for maximizing the worth of every tree. Loading these logs onto trucks is its own specialized operation. The loaders used in modern forestry operations are remarkable machines, with articulated booms that can reach out 30 feet or more, equipped with hydraulic grapples that can pick up several tons of logs at once. The loader operator arranges the logs on the truck bed like a three-dimensional puzzle, maximizing the load while keeping it balanced and secure. It's a skill that takes years to master, and a good loader operator is worth their weight in gold to a logging crew. The journey from forest to mill might be 50 miles or more, depending on where the logging operation is taking place. These log trucks, fully loaded, can weigh 80,000 pounds or more, and they're traveling on roads that range from modern highways to rough logging trails. The drivers are specialists in their own right, handling vehicles that would intimidate most professional truckers. There's a camaraderie among log truck drivers that goes back generations. They're part of a tradition that helped build America, hauling the timber that became the homes, barns, and businesses of a growing nation. When those trucks arrive at the MC Dixon mill, they're greeted by a facility that's been refined and improved over decades of operation. The mill yard itself is a marvel of logistics. At any given time, Dixon might have thousands of logs in inventory, representing dozens of species and quality grades. These logs are sorted and stored by species and size class, creating a reserve that allows the mill to optimize production runs and meet customer orders efficiently. The unloading process is efficient and carefully choreographed. A hydraulic boom lifts logs from the trucks and places them in designated areas of the yard. Even at this early stage, quality control is paramount. Yard workers are checking logs for defects, measuring diameters, and noting characteristics that will affect how each log is processed. Any log with signs of rot, excessive shake, that's internal splitting, or other major defects is set aside for alternative uses. Before processing begins, many logs go through a period of water storage, especially during warm weather. Dixon maintains large log ponds or uses water spray systems to keep logs moist. This serves multiple purposes. It prevents checking those surface cracks that can degrade lumber quality. It keeps the logs clean for better saw performance, and it can actually help loosen bark for easier removal. This practice dates back to the earliest days of sawmilling, when mills were built next to rivers and logs were stored in the water naturally. The debarking operation at Dixon uses a combination of methods depending on the species and log size. For larger diameter logs, they employ ring debarkers similar to what we saw at Koddenbrock, but Dixon also uses drum debarkers for processing smaller logs in batches. Picture a giant rotating drum, like the world's most aggressive clothes dryer, where logs tumble against each other and the drum's interior, knocking off bark through friction and impact. It's rough but effective, especially for species with loosely attached bark. Here's a bit of history that might interest you. Bark removal was one of the first operations to be mechanized in sawmills. Before mechanical debarkers, workers would manually peel bark using specialized tools, backbreaking work that was both dangerous and inefficient. The development of mechanical debarking in the early 20th century was a revolution in the industry, increasing productivity and improving worker safety. Today's automated systems would seem like science fiction to those early mill workers. After debarking, logs moved to Dixon's metal detection system. Now, you might wonder why you'd need to detect metal in a log. Well, trees growing near old settlements, fence lines, or roads can have all sorts of metal embedded in them. Nails, barbed wire, even bullets from hunters. A saw blade hitting metal at operating speed can shatter, sending blade fragments flying like shrapnel. Modern metal detectors can locate metal objects deep within the log, alerting operators to potential hazards. When metal is detected, that section of the log might be cut out before sawing, or the log might be set aside for more careful processing. The scanning and optimization system at Dixon represents a significant investment in technology, but it's paid for itself many times over. As logs move along the in-feed conveyor, they pass through a scanning station where multiple cameras and laser profilers capture detailed data. The computer analyzes this information and determines the optimal sawing pattern in milliseconds. This might seem like a modern innovation, but the principle goes back to the earliest days of sawmilling, getting the most value out of every log. The difference is that computers can calculate solutions that even the most experienced sawyer might miss. Dixon's primary breakdown system includes both band mill and circular saw head rigs, chosen based on log size and species. The band mill excels at slicing through large diameter hardwoods with minimal waste. That thin blade doesn't remove much wood as sawdust. For smaller logs and higher production rates, circular saws are often more efficient. The choice between the two is part science, part economics, and part traditional preference. Watching the head rig in operation is mesmerizing. The log enters, the saw screams through the first cut, the log rotates precisely 90 degrees, another cut, another rotation. Within a minute or two, a 300-pound log has been transformed into a neat stack of cants and slabs. The cant is the squared center section, while the slabs are those first cuts with one flat side and one curved side with bark remnants. Nothing is wasted. Those slabs will be further processed or used for other products. The resaw operations at Dixon are where the real diversity of products emerges. Multiple resaw lines operate simultaneously, each configured for different target dimensions. One line might be producing 4/4 material, that's 1 inch thick in lumber terminology, while another produces 8/4, 2-inch stock for thicker applications. The terminology dates back to when board thickness was measured in 1/4-inch increments, and even though we use decimal measurements now, the old terms persist because they're so deeply embedded in the industry's vocabulary. Edging operations require keen judgment and quick decision-making. As each board comes to the edger, the operator has seconds to decide where to position the cuts. They're looking for the optimal balance between board width and defects. Sometimes a board can be edged to remove a defect on one side, producing a narrower but higher grade piece. Other times, keeping the board wider with a defect included yields more value. These split-second decisions, multiplied thousands of times per day, have enormous impact on the mill's profitability. The trim saws make the final length cuts, squaring the board ends and cutting to standard lengths. In hardwood lumber, common lengths are 4 feet to 16 feet in 1-foot increments. The trim saw operator is making yet another optimization decision with each board. Should this 12-foot board with a defect in one end be cut down to 10 feet of clear wood, or is there more value in keeping the full length and accepting a lower grade? Grading hardwood lumber is an art form that takes years to master. Dixon employs graders who have decades of experience and can evaluate a board in seconds. They're looking at the percentage of clear wood, areas free from knots, splits, and other defects. They're considering grain patterns, color variation, and dozens of other factors. The National Hardwood Lumber Association rules provide the framework, but application requires judgment and experience. A board that's borderline between grades might go either way depending on the grader's assessment, and good graders are consistent and fair in their evaluations. Here's something that many people don't realize. Different wood species have different grading rules. Cherry lumber is evaluated differently than white oak, which has different standards than hard maple. This is because each species has characteristic features and defects that appear differently. A small pin knot might be acceptable in one species but downgrade another. Learning these distinctions is part of what makes hardwood grading such a specialized skill. The sorting and stacking operation is where processed lumber is organized for drying and shipment. Boards of the same species, thickness, grade, and moisture content are stacked together with precise spacing. Those stickers I mentioned earlier, thin strips of wood placed between layers, are positioned every 12 to 16 inches along the length of each board. This creates air channels that promote even drying and prevent mold growth. The stacks might be 8 feet tall or more, containing thousands of board feet of lumber. They're built with care because a poorly stacked load can result in warped, stained, or damaged lumber. MC Dixon, like many American hardwood mills, represents a connection to our nation's industrial heritage. These operations evolved from small, water-powered mills that served local communities to sophisticated manufacturing facilities serving global markets. Yet, despite all the technological advancement, the fundamental nature of the work remains the same, transforming trees into useful lumber while respecting both the material and the craft. The men and women working at Dixon are part of a tradition that stretches back generations, and they take pride in carrying that tradition forward while embracing innovation. The lumber leaving Dixon's facility will find its way into countless applications: flooring in homes from coast to coast, cabinets in kitchens and bathrooms, furniture crafted by skilled woodworkers, architectural millwork in commercial buildings, and specialty products for everything from musical instruments to boat building. Each board carries within it not just the growth rings of the tree that produced it, but the expertise and care of every person involved in its production. Hampton Lumber and Family Forests represent something special in the American timber industry, a vertically integrated operation where forest management and lumber production are parts of a unified whole. Founded generations ago, Hampton has grown from a small family operation into one of the premier lumber producers in the Pacific Northwest, yet they've maintained that family business commitment to quality and sustainability. Their processing facility is a testament to continuous improvement and investment in both people and technology. Walking through the Hampton Mill, you see the latest in computerized scanning and optimization systems working alongside craftsmen whose families have worked in timber for generations. It's this blend of innovation and tradition that defines their approach. The lumber flowing through Hampton's facility is primarily Douglas fir, western hemlock, and other Pacific Northwest species, softwoods that have built America's homes for over a century. These species have different characteristics than the hardwoods we've been discussing, and Hampton's equipment is specifically configured to handle them efficiently. Their headrig systems can process logs at remarkable speeds, while their edging and trimming operations are calibrated for the precision that modern construction demands. Their drying kilns use modern computer controls to manage temperature, humidity, and airflow with precision, producing lumber that meets exact moisture content specifications. The finished lumber is graded, tallied, and packaged for shipment to customers, ranging from major home centers to local lumber yards. Each package is marked with species, grade, and moisture content information, giving customers confidence in what they're buying. Hampton's commitment to utilizing every part of the log is evident throughout their operation. Bark becomes fuel for their boilers, sawdust is sold for particle board manufacturing, and chips go to pulp mills. This closed-loop approach represents modern forestry at its best: sustainable, efficient, and environmentally responsible. It's a far cry from the wasteful practices of earlier eras, and it represents the future of the industry.